Hello everyone, welcome to my channel Prochem Academy. Now in today's video I will discuss about another topic of atomic structure, that is how to calculate the radius of the orbit, like Bohr like orbit, and the energy of the electron which is present in that orbit, that means energy of nth orbit electron. So that one we will try to calculate according to Bohr's theory. Now in last class I have discussed about the Bohr's atomic structure, that means Bohr's theory of atomic structure, and there we know that the orbits will be circular in nature, and surrounding the nucleus in different orbit, electron will revolve in different orbit. In those orbits they will revolve which are quantized, that is the angular momentum of that electron will be integral multiple of h by 2 pi. In those orbits electron will be revolved. Now so we are going to calculate the radius of that orbit where the electron is. Now see, if this is the nucleus, this is the nucleus of Bohr like orbit, Bohr like atom actually, and this is the electron which is revolving in a certain orbit. We are going to calculate these all are energy states. This is the first orbit and this is the energy state actually. So electron can be there in any one of the orbit, so we are going to calculate the radius of that orbit. So the electron is here, and it is the radius of the atom, that is the from the distance from the nucleus to the electron. And thus, as this electron has a particular mass, it is a particle, so electron will have a particular mass, that is m, and the velocity will be tangential velocity as it is rotating in a circular path, so it is v. So let us consider the mass of revolving electron is m, radius of the orbit where the electron is present is r, charge of electron is E, and charge of nucleus we have to take as Ze. This is denoted as Ze, charge of nucleus, because the atomic number denotes as Z and the nucleus will have the charge Ze. Now according to the actually electrical theory, that as nucleus is positive center, its charge is Ze, and the electron is negative center, so it will attract each other. So nucleus will attract this electron by towards this center of the circle, that is centripetal force, or that will be equal to the Coulombic attraction force. The electron will be attracted towards the nucleus, that is nothing but the Coulombic attraction force, and it is similar with the centripetal force. So as this nucleus is attracting this electron towards itself, so the electron is not coming towards the nucleus. Why? Because there is the opposite force is there which is acting to the outside of this circle, that is opposite to the centripetal force, but equal in magnitude. That one is called centrifugal force. So nucleus will attract this electron by Coulombic attraction force, and there will be outside another force will be there, that is the centrifugal force, which is neutralizing this attraction force, centrifugal force, which is neutralizing this centripetal force. So both this centrifugal force and this centripetal force, that means the Coulombic attraction force will be equal. So what we have learned, that this Coulombic attraction force will be neutralized by the centrifugal force, so that the electron will not come into the nucleus. That is the reason. Now according to Coulomb's theory, according to Coulomb's law, according to Coulomb's law, if two charged particle, one is positive charge, one is negative charge, those magnitudes of the charges is plus Zd and the charge of the electron is E, and they are separated by a distance r. The Coulombic attraction force will be directly proportional to the product of these two charges, okay, Z into E, and will be inversely proportional to the distance of the square of the charges, that means 1 by r square. Then if you join together this one, that by the law of variation you will get F proportional to Z E into E by r square. Now if you replace this proportional sign by equal sign, you will get a constant, that is K, which is called proportionally constant, and you will get Z square by r square. Now this K has a particular significance. This K depends on the medium. The value of this K, that means value of this constant, is depends on particular medium. Okay, how it is depends? Actually, for if you take the value of this force, that means centrifugal force, here is the Coulombic attraction force in SI, then the value will be K, value of K will be there. Okay, and that will depend on the permittivity, that means absolute permittivity of the medium. Okay, absolute permittivity of the medium. Okay, this one you have copied, I think. Okay, just I am erasing this one because I have to write. So I am erasing this one. So the value of K depends on the medium, that is 1 by 4 pi epsilon 0, and epsilon 0 is the absolute permittivity of the medium. Okay, of the medium. And if you put the value of absolute permittivity, that means 8.85 10 to the minus 12, then you will get the value of K in SI, actually in SI, and in SI you will get 9 10 to the power 9. Okay, Newton meter square Coulomb to the power minus 2. So when you are calculating the radius and in SI unit, then you can put the value of K here, which is 9 10 to the power 9 Newton meter square Coulomb to the power minus 2. But in CGS, the value of K will be 1, and that will shorten the relation. Okay, we are going to make a relation which will be proper and easy. That relation we have to make. So we will not calculate the K value of radius by putting the value of K like 9 10 to the power 9. We can do, but it will be easier if we go by the CGS unit. If we go by the CGS unit, it will be easier. Okay, but same thing I will tell you about the SI unit also. Okay, so just see, first of all we will try to arrange the relation. Okay, after that we will calculate. So if the you are calculating in CGS unit, then this relation, that means F is equal to K into Z square by R square will become F equal Z square by R square, because K you are taking as 1, that means in CGS unit. Okay, now this is the centripetal force or Coulombic attraction force, and it is neutralized by equal force but opposite, that is centrifugal force. Now the particle which is moving by velocity v and mass m, and it is in distance r from the center of a circle, its centrifugal force is mv square by r. Now this mv square by r is equal to z square by r square. Okay, so these both will be equal, will equal these two things. Okay, so according to, so what we can write, that centrifugal force is equal to the centripetal force. So what we can write, that z square by r square equal mv square by, again I am telling, I have taken this K as 1 because in CGS unit. Okay, so what in CGS unit the whole calculation will be done in the CGS unit. Now what will be the, first of all we calculate the value of v square from here, then we will get from here that this will be multiplied, so z square by mr you will get z square by mr. Mark this equation as 1. Okay, so just copy up to this, z square by mr will be equation 1. We have calculated from this, just the v square from here, equaling these two things. Okay, now we are going to calculate the radius of an Bohr orbit. Okay, that means Bohr's theory will be applicable here, and that is nothing but mvr equal nh by 2 pi. You already learned by the last class that mvr equal nh by 2 pi. So Bohr theory will be applicable here. Now you see, according to Bohr's theory, okay, according to Bohr's theory, mvr equal nh by 2 pi. Now what do you want to calculate from here? We will calculate V from here, NH by 2 pi mr. Now we are going to equal from V square we have got from here also. We are going to calculate the value of V square from here also, so that both will be equal, and we are going to calculate the R from there. We can calculate the R from there also, equating by this equation and that equation. Okay, so here we can write V square. So V square will be n square h square by 4 pi square m square r square. This is equation 2. Now this V square, both V square are equal, so we can, by equation 1 and equation 2 we can write, okay, by equation 1 and equation 2, by equation 1 and 2, what we can write? N square h square by 4 pi square m square r square. And from equation 1 what we have got, actually I have just erased that one, z square by r square equal mv square by r. We have got v square equal z square by mr. Okay, so we have to put here z square by mr. Now we will calculate r from here. How we will calculate this? R will be connected by this r, m sorry. So what you are getting, actually you are getting that n square h square equal 4 pi square z square r. So what will be the r? R will be n square h square by 4 pi square z square. Okay, this is the equation of the radius of the electron which is present in the nth orbit. So this can be written as Rn, which is present in the nth orbit. So Rn equal n square h square by 4 pi square z square. Okay, n square, so one m will be there, I think one m will be there, so m will be written here only. So n square h square by 4 pi square m z square. Okay, m z square. This equation is for CGS. Okay, but if you put the value of k, then k will come here. Okay, understood? So this is the radius of the orbit. This is the radius of the orbit. Just wait a minute. Just I'll start the calculation of En also. Wait. Okay, so this is the value of radius of the orbit, that means nth orbit, that is n square h square by 4 pi square m z square. Now here you see all are constant, actually all are constant except this your n square and z, because n is the number of the orbit and z is the atomic number, and atomic number will vary species to species. For hydrogen it will be 1, and this theory will be applicable for the hydrogen like atom, okay, or hydrogen like species. Now Rn equal, you can write that h square by 4 pi square m square into n square by z. Now if you put the value of this constant, then you will get a value, okay, that will help you to calculate the numerical problems. Okay, for the numerical problem, that will help you. Now here this Rn equal, if you put the value, then you will get this one, 0.529 into 10 to the power minus 10 meter, okay, into n square by z. Okay, in SI unit or series unit you will get this one. In SI unit you will get 0.53, and series unit you will get 0.529 if you put the value. So this is also important. Okay, and 0.529 into 10 to the power minus 8 centimeter into n square by z. This is in the, actually in CGS, actually you will get 0.529 into the minus 8 n square by z, and you can convert it in Armstrong also. So you will get 0.529 into n square by z Armstrong. Okay, 0.529 into n square by z Armstrong. Okay, now this, why this n is different? Because the value, this n signifies the principal quantum number, and this is the number of the orbit. That means for n k orbit, the value of n equal 1. For L orbit, the value of n equal 2, and for hydrogen like atom, z equal 1. Okay, so you will get, if you put z 1 here, then you will get this one. to n square Armstrong. Okay, because z equal 1 here. So actually this 0.529 Armstrong is the radius of first Bohr orbit, that means k orbit, because if you put 1 here, then it will be 1 square, so 0.529 Armstrong you will get. Okay, for the first Bohr orbit. For the second Bohr orbit it will be 2 square, so different value will get, but the radius of first Bohr orbit will be 0.529 Armstrong. Okay, but this relation is very important because this will help you to calculate the energy of the electron which is revolving in nth Bohr orbit. Okay, which is revolving in nth Bohr orbit. Now I am erasing this one. I am going to calculate the total energy of the electron which is revolving in a nth Bohr orbit. Okay, now say the electron is revolving here. This is the nucleus and this is the circular orbit. Electron is revolving here, so it will have a velocity and mass will be m, and radius of the is r. Now as the electron is a particle which is revolving in a circular orbit, it will consist of kinetic energy also and potential energy also, and the sum of kinetic energy and the potential energy will be the total energy of the electron. Okay, now what is the kinetic energy? Kinetic energy of the electron which is revolving, it can be denoted by Ek. It can be denoted by Ek, which is revolving in a circular orbit having mass m, velocity v, and radius r. It will be half mv square. It will be half mv square. This one will know. But what will be the kinetic energy of the what will be the potential energy of the electron revolving in nth orbit? Okay. Now potential energy we can calculate by the definition. Actually, you know the definition of potential energy, that is the total work done. Okay, total work done to bring a electron from infinite to the radius r. Okay, and for that we have to overcome the centripetal force of attraction of the nucleus. Okay, that is nothing but z square by r square. Okay, so in that case we have to sum infinite number of work done. So in that case we will integrate. We have to integrate within the integrating range, actually infinite to r, within the limit infinite to r, and we have to overcome the centripetal force z square by r square. Okay, with the function dr. Understood? So here to calculate the potential energy EP, we have to integrate with the range infinite to r, because we are taking the electron, we are bringing the electron from infinite to r, z square by r square dr. Now we have to integrate this one. Okay, now as according to the integration rule, z square is constant, so it will come first, dr by r square. Now okay, now I am not erasing this one because this will be recorded after that, so I am erasing this one. Okay, just you copy this one. So here z square infinity to r, r to the power minus 2 dr. It can be written 1 by r square, that means r to the power minus 2. Now z square. Now the formula of integration, this is for those students who don't know actually the formula of integration. Okay, and for the newcomer 11 students. Okay, so here this is the integration sign, and if dx is the, okay, wait a minute. Okay, so you are getting infinite to r, up to the power minus 2 dr. Okay, so what is the rule actually? Dx, if the function is dx and you are integrating with this x to the power n, then the rule is x to the power n plus 1 by n plus 1 plus c. This is the rule of the integration. Now we will follow this one, we will do the integration. Okay, now here instead of x, r is written, instead of n minus 2 is written, and instead of dx, dr is written. Okay, so we have to integrate here. Now before integration we have to give a square bracket, because this integration is the finite integration, and we have to give a square bracket, and here we have to write the limit. Now we will calculate the value according to this rule and put it here. Okay, so here you see what will be the rule: r minus 2 plus 1. Just see the rules and put it here. Okay, so r to the power minus 2 plus 1 minus 2 plus 1. Now what you are getting here, z is square up to the power minus 1 by minus 1 r infinite. Okay, understood? So this is nothing but z square 1 by r. This is nothing but 1 by r to infinite minus 1 by r. Now we have to put the limit, because this integration is the finite integration. So whenever we are doing the finite integration, you have to put the upper limit first, then the lower limit. Okay, so put here the upper limit first. Okay, so z square minus 1 by r minus 1 by infinity. Upper limit, instead of this r we are writing r, because upper limit is r, minus lower limit is infinity. Okay, so here what you are getting actually minus z square by r, because this 1 by infinity is 0. So here the potential energy we are getting EP minus z square by r. Now total energy will be minus z square by r plus half mv square, because total energy is E total will be Ek plus Ep. Now this Ek is half mv square and this Ep is nothing but z square by r. Now we have to add this one, but how will I add? We don't know. That means mv square half mv square and this z square by r cannot be added. So what we will try to do, we will substitute the value of mv square here. Okay, from where we will substitute, we know that, just I am using this one, we know that mv square by r or z square by r square, that means Coulombic force of attraction, is equal to the mv square by r. So here we can get the value of mv square, that means z square by r. So this value of mv square we will put here only. Okay, we will put here only E total half z square by r minus z square. So it will help us to calculate the proper value. Now 2r will be the LCM, so you will get z square minus 2 z square, so you will get minus z square by 2r. Okay, this is the total energy. Now if you substitute the value of r from here, then you will get a value of total energy, which will consist of m, that means the number of orbit, time constant, pi, m, mass of the electron. Okay, all the things you will get. So just substitute the value z square by 2. So value of r here n square h square by 4 pi square m z square. Okay, so this will be cut by 2. So you will get minus 2 pi square, okay, m, this z will be z multiplied with this z, so you will get z square, e square into e square to the power 4 by n square h square. So this is the overall energy of the electron which is present, which is rotating in the nth orbit, minus 2 pi square m z square to the power 4 by n square h square. You can memorize this one, these two formula, and this is also for CGS unit. Okay, understood? Now if you see here that all the things except all the terms except z square and n square are constant. So if you put the value, then you will get minus 13.6 into z square by n square in electron volt unit. Okay, by dividing by the charge of the electron, it will be converted to electron volt. Now this is the formula of the En minus 13.6 z square by n square. Now for the first Bohr orbit, the value of energy is minus 13.6, because this is the first orbit. For hydrogen like atom, actually for hydrogen z will be 1, and for first Bohr orbit n will be 1, so you will get minus 13.6. For second orbit, third orbit will be changed. Okay, so this is the energy of the nth orbit electron, and this is the radius. So these two are very important. So today's video is up to this. If you have any doubt regarding this today's topic, you can ask me over comment box, so I can make another video. Okay, and if you like this video, then do like, comment and subscribe my channel. Thank you.